Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus. And so we've got 12X. And then on the last bus stop, 19 passengers get on. So plus 19. Now for the second bus, well, we start with X and a further 5X come on. Because 5 bus stops with X passengers. So that's 6X altogether. And then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less. And the way we show that is with this inequality here. Now all we need to do is solve that inequality. And we've got x on both sides, so we look at the x's. We've got 12x and 6x, so we always take away the smaller amount. So we're going to take away the 6x both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got x is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for x? Now, it is tempting to write down 10, but it says x has to be less than 10. So the biggest number we can get that is less than 10 is 9. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2,115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4X. Robert has 69 fewer merit points than James, so he's going to have X minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more. So she will have 516. And Robert has 69 fewer. So we're going to take 69 away from that. And that will equal 60. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now, we've got this proportionality sign here. And to make that an equals, all we need to do is introduce a k constant to the right-hand side. So it's y equals something times x. Now, to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. and 55.3 divided by 7 is 7.9, and that's what k is. So we're going to rewrite this equation here, this formula here, y equals 7.9x, and that is actually our answer. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. The important thing to realise in this question is that we know a female has been selected. So we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female's been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. So let's look through this question to see what information we're given and what information we're looking for. So we're given the acceleration is 13 meters per second squared. We're also given the distance is 19. And we're also given the end velocity, which is v, is 34. And we're looking for the initial velocity. So which of these formulae include A, S, V, and U? that's got a t in it, that's got a t in it, so it's going to be this one here. So let's write that out. V squared equals u squared plus 2as. So that would be 34 squared equals u squared, because that's what the one we're looking for, plus 2 times 13 times 19. Okay, so let's just work these parts out. And so we've got 2 times 13 times 19, which is what, 494. And it turns into a solving part, so we're just going to solve this. So the first thing I'm going to do is subtract 494 from both sides. And so we're left with 662 equals u squared. Then we're just going to square root both sides. And so square root of that is going to be 25.729 blah blah blah. And it says it wants it to 2 decimal places, so it's going to be 25.73. So to make estimates from a scatter graph, we've got to first of all draw a line of best fit, which would be something like this. And what we'll do is to find estimate of test score B, given the fact they got 25 on test A, means that we would draw a line up from test A at 25, should be here, and then across, and that's how we'd make the estimate. But look at where that is hitting our line of best fit. It's hitting it here. What do you notice about this position here? Well, all of our data is down here. We don't know whether this trend continues up at this point here. We have no idea. For instance, if you were to plot a scatter graph of height against age, we would see it would increase like that, but that line doesn't continue on forever. Like, you're not a 10-foot giant at the age of 30. You do slowly stop growing, and so we don't know whether the trend continues. So we call this extrapolation. So we say that the data has been extrapolated, and what that means is it is probably not accurate. So when you have the data outside the range of the data, when you have a prediction, outside the range of the data, we say it's probably not accurate. If it was inside the data, we would say it's interpolated, and that's actually quite accurate. This question seems a lot harder than it is. What I'm going to do is I'm going to start by rewriting the prime factors, but without the squared. So 2 times 3 times 3 times 5 times 5. I'm going to do the same with the other list as well. So 2 times 2 times 3 times 11. Now I'm going to put these into a Venn diagram. And so I'm just going to draw out a Venn diagram and get my 2 circles, because we're going to have the 450 and the 132. So 450 is on the left hand side and 132 is on the right hand side. And we're going to start just filling out the Venn diagram. So they both have a 2 in them and they both have a 3, but 450 has a 3, a 5 and a 5. And 132 has that 2 and the 11. Now to find the lowest common multiple, what you do is you just multiply all these numbers together, and that will give you the lowest common multiple. So what we're going to do is we're going to do 3 times 5 times 5, which are the numbers on the left, times 2 times 3, which are the numbers in the middle, times 2 times 11. And when we do that, we get 9,900, and that's it. So our answer is 9,900. So we need to first of all work out the amount of machine minutes it takes to make a toy. And what we do is we multiply the amount of machines by the amount of minutes. So 5 times 40, which would be 200. So if we had one machine, it would take 200 minutes to create one toy. Here we're asked well, okay, what if we wanted a toy every 8 minutes? So we get the 200 and we divide it by 8. And when we do that, we get 25. So if we had 25 machines, we would be able to make it every 8 minutes. And the logic here is 5 machines. So this is machines, and this is minutes, is 40. Then 8 minutes, if you think about it, we divide that by 5 to get to 8. And so if we divide the amount of minutes by 5, we actually times the amount of machines required by 5. So this is called an inverse relationship. So if one doubles, the other halves. If one divided by 5, the other will times by 5. So our answer here is 25 machines. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10. So the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the two numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120, and we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. So we're given 21 to 4 is the ratio. And we're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay. And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1, perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. To find average speed, we do the total distance and we divide it by the total time. Now in this question we've got a bit of an issue because the question wants kilometers per hour, but the units are given to us in meters and minutes. So we just need to do some basic conversions. So 1080 meters is going to be 1.08 kilometers because there are 1,000 meters in a kilometer, so all we need to do is just divide the meters by 1,000. Minutes are a little bit trickier. To get from minutes to hours, all we need to do is divide by 60. And so when you divide that by 60, you get 0.2 hours. So we're going to put the kilometers at the top, 1.08, and we're going to divide that by the hours, which is 0.2. When you do that, you get 5.4. So our answer to 2 decimal places will be 5.40. Whenever you have a one-digit number or a 1 decimal place number, but you're asked to round it to 2 decimal places, you should really put a 0 on the end, which is what we've done. So this question is a simultaneous equations question, And so we're going to have to write down some equations. So it says 2 apples and 3 pears cost £3.80. So 2 apples, I'm going to call it A for the price of an apple, plus 3 pears, so 3p, cost £3.80. Now I'm going to do this as 380 just because it's easier to work with integers rather than decimals. And it says 3 apples, so 3a, plus 8 pears costs £7.80, or 780 pence. Okay, so the first thing I do is try and get these numbers the same. So 3 and 8, they both go into 24, so I need to make them both 24. And what some people do is they just label this A and this B. And so what we're going to do here is we're going to multiply everything in equation A by 8, so that this becomes 24. So it's going to become 8a. And so we're going to times the 2a by 8, which will be 16a plus 24p, and 380 times 8 is 3040. And we're going to do the same with b, but this time we're going to times it by 3, so we're going to have 3b. And we're just going through everything here and we're timesing it by 3. So 9a plus 24p, which is good, that's what we wanted. And 780 times 3 is 2340. So now we've got both of these the same coefficient. What we can do is we can eliminate going downwards. Now, if they are the same, the s in same is the s in subtract. If they were different signs, so if these weren't both positive, if one of them was negative, different, the d in different is the d in add. So here they are the same, so we are going to subtract, and we're going to subtract going downwards. So we're going to start off by doing, and I can just do a little line here to show what we're doing. So we're subtracting going downwards, and we're going to do 16a take away 9a, which will be 7a. 24p take away 24p, which is nothing, which is why we did that, is to eliminate them. And then 3040 take away 2340 will be 700. Then I can put my lines in, and all I need to do now is just divide both sides by 7, and I get A equals 100. So we know that apples cost 100, or £1. We need to work out what pears cost. So I just need to pick one of the equations. I'm just going to pick this top one here, and I'm going to write it out. But instead of A, we know that A is £1, or 100 pence. So plus 3p equals 380. So that's going to be 200 plus 3p is 380. And then again, I'm just going to draw my lines down. And we're going to subtract 200 from both sides. So it's going to be 3p equals 180. And then we're going to just divide by 3 both sides. And we've got p equals 60. So a pear costs 60. Now we can check this by using the other equation there. So 3 times 100 is 300, plus 8 lots of 60 is going to be, what's that, 480? So that's going to be 780. So we know that we've got it right. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. Okay, so we're going to start off by working out the multiplier, and we're told, we always start off with 100%, we're told that the compound interest rate is 1.6%. So we're going to add 1.6% to the 100%, and it's going to be 101.6%. Okay, make that into a decimal by dividing it by 100. So we're just going to divide that by 100, and this will give us the decimal or the multiplier. So the multiplier is 1.016. And so anytime we want to increase something by 1.6%, we just times it by 1.016. Now, we're told that we start off with 2,400. That's our original amount. And to find out what it's going to be in the savings account at the end of the first year, we just times it by the multiplier, 1.016. But we're told that it's for 7 years that it's going to be in there. So we then times it by 1.0167 times, or easier way of doing it is 1.016 to the power of 7. When we do that, we get 2,682.052 blah blah blah, and because it's money, we round to the nearest pence, so 2,682.05. It's sometimes easier in these questions to view these triangles as two separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side so we can see what's going on. I'm going to do the same with the smaller triangle and kind of move that to the side. So we can see we've got two triangles here. We've got a big triangle and small triangle. And we can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now the two triangles are similar because the sides here we assume are, we know they are parallel because they are right angles. And they share an angle here, which we can just label as A. And so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now, if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. Subtract x both sides. Always subtract the smaller amount, so 2x equals 20. And then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. To start these questions, we always start here, and we go down the lines. So it says probability of winning both games. So we're going to go up this one, and we're going to pass this fraction here, and then we're going to win the second game. So we'll go up this one, and cross this fraction here. Now the bit at the end will show us the probability of winning game 1 and the probability of winning game 2. So probability of winning game 1 was the first fraction we circled, which was 10 over 11. Probability of winning game 2 was the second one we've circled, which is 4 over 5. The word and in probability means times. So we're going to times the tops, which is 40, times the bottom, which is 55. And we can divide top and bottom by 5, so that will give us the probability of 8 over 11. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4. And 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So we're asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out. And we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. To work out the area of this sector, there is actually a nice little formula that we can use. And I'm just going to show you what the formula means. So the formula is going to be what fraction of the full circle do we have? Okay, so we're going to find out the fraction of the full circle we have, and then we're going to times that by the area of the circle. So to work out the fraction of the circle we have, we get the angle that we have in the sector, and we divide that by the total amount of angles in a circle, which is 360. Then we times that by the area of a circle, so pi r squared. Let's use that for our question. So the angle we have for this question is 57 times pi r. Now, to work out what r is, we just imagine the circle is whole. I'll do a badly drawn circle. And you can see here that this length here, this 5 centimeters, is the distance between the center of the circle and the circumference. So that is a radius. So it's going to be times 5 squared. Put that into your calculator and you'll get 12.435 blah blah blah. And it says it wants its 2 decimal places, so we round that to 12.44 centimeters squared. When solving simultaneous equations graphically, if you draw the lines to both graphs, which we have done here, the solutions, or solution, because they're both linear, will just be where the 2 graphs cross. So this here will be our solution. So x is 2 and y is minus 4. So here we're asked for a minus b. So in our vector we're going to do a, which at the top is 5, take away b, which at the top is 4. And we're going to do the same with the bottom. So we're going to take away the minus 2, take away the 7. 5 take away 4 is going to be 1. Minus 2 minus 7 is going to be minus 9. So our vector will be 1 at the top and minus 9 at the bottom. First thing we need to do is find out what 10% of the 109 is. So we're just going to multiply by 0.1. and that gives us 10.9. So what we're going to do is we're going to add and subtract this from 109. So we're going to do 109 take away 10.9, which gives us 98.1. And then we're going to do 109 plus 10.9, which will give us 119.9. So our error interval is between 98.1, and it says to use t, and 119.9. So I'm going to write this equation again just a little bit bigger so we can work with it. And one of the rules with equations is you want to get rid of brackets and fractions first. So we've got a big fraction here, and basically a fraction just means divide. So we're doing the 82 and we're dividing it by 3x plus 5. Notice I've put a bracket around it, because what we're going to do is we're going to do the opposite of divide by that bracket. We're going to times both sides by 3x plus 5 to get rid of that fraction. Now on the left hand side that just gets rid of the fraction, so we're just left with 82. On the right hand side, well, we're doing the 2 times the 3x plus 5. Following my rules to get rid of all the brackets first. So 2 times 3x is 6x, 2 times 5 is 10. And you can use any method you want. Some of you might use this method where we've got the 2 here, 3x plus the 5, and then we times them, so it's 6x plus 10. That's how we can do it. Any method you like. And then we're going to take away the 10 both sides because we want x on its own. And so we've got 72 equals 6x. And then we're going to divide both sides by 6. And so we've got 12 equals x, or x equals 12. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100. So that would be 65%. We've got to first of all work out the equation of the line given to us. And it's horizontal, so it's going to be a y equals line, and it crosses the y-axis at 2.5. So it's going to be the line y equals 2.5. Now, there are lots of different inequalities that would involve the line y equals 2.5. We've got y is greater than 2.5, y is less than 2.5, y is greater than or equal to 2.5, and y is less than or equal to 2.5. So we've got to work out which one of these it is. Now, when we've got a dashed line, it means it cannot be equal to, so that gets rid of these two. And if we pick a coordinate, let's pick this one here, on our region side, it is 8, 8. Now look at the y coordinate, which is 8. That is actually more than 2.5. So it's not less than 2.5, it's going to be more than 2.5. So its y is greater than 2.5. An exponential growth would show an increase from left to right, but the graph we've got in front of us, or the sketch, is showing it decreasing, so it's going to be a decay. So we're going to go through one way in which you can do this question. With circle theorems, often there are multiple different approaches, and so if you do a slightly different method, but you've written down all the working and you're happy with it, and you get the same answer, it's probably fine. Just don't forget with these, always show every step of your working out, because normally, say there's 3 marks for this question, 1 will be for the answer and 2 will be for the working out. So the first thing I notice with this question is that we have a lovely triangle coming off a tangent, and whenever we have that, the angle on the outside here is equal to the angle on the opposite side of the triangle. So this is going to be 44 here. I'm just going to remove all of that. and so this is going to be 44 degrees here. So angle BFD equals 44 degrees, and the reason you need to give is the alternate segment theorem, and you have to use those words, otherwise you won't get the marks. Now next I noticed that we've got a set of parallel lines here, and we've got a line going through them, and so the 44 degrees there is going to be equal to this one here, and so this is going to be 44 degrees. So we say angle FDE equals 44 degrees, and the reason this time is alternate angles, put the E in, angles, and again you have to use the word alternate. Okay, next thing I notice is that we have an isosceles triangle here, here and here, and the bottom two angles in isosceles, assuming that it's upright, are always equal. So this is going to be 44 degrees here. So angle EFD is also 44 degrees, and again we have to just say that it's an isosceles triangle. Okay, just highlight the fact it's an isosceles triangle. Okay, next thing we're going to work out is this one here, and it's just angles in a triangle. So angle FED is going to be 180, take away the 44 plus the 44, and the reason is angles in a triangle add up to 180 degrees, and so 180 take away the 44 plus the 44 is 92 degrees. And finally, took us a while to get there, but finally we can work out what this angle is, because in total all four corners of this quadrilateral here are touching the circle, so it's a cyclic quadrilateral. And so angle, what's it called in the question, angle FBD is going to equal 180 take away 92, and again we have to show the reason of the fact it's a cyclic quadrilateral. And so 180 take away 92 is going to be 88 degrees. So our answer will be 88 degrees. Okay, so we're asked to find length AB, which is this length here. But I'm going to start just by renaming these letters. And I'm going to put this as a capital C, and this as a capital A, and a lowercase a over here. And the reason it being is that we're going to use this formula, which is area equals half AB sine C. And you can see that the angle C is a C in this formula, and so I've just changed it to a C here. And so we're looking for little a. We're not interested in little c or big B or big A. We're focused on, and we've got a little b here, we're focused on little b, little a, and big C. The area is given to us in the question is 21.6, and we're looking for A, but B is 5 and C is 68. And so all we need to do here is rearrange all of this. And we're going to start just by working out what half times 5 times sine 68 is. And that's going to be 2.317 blah blah blah. That's times A. And then we're going to do a bit of solving, because if we divide both sides by that 2.317 blah blah blah, that'll give us what A is. So when we do that, we get 9.318 blah 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 equals A. So rounded to 2 decimal places, that's going to be 2.32. So we know that the cuboids are similar, so there's going to be scale factors. And we're given the two surface areas, so we're going to first of all start there. And we know that there's going to be a scale factor between them. So what do we times the 9 by to get to the 272.25? So we're going to do 272.25, the big one divided by the small one, to find out what the area scale factor is. And when we do that, we get 30.25. So the area scale factor is 30.25. Now this question is all about volume, but we're going to work a little bit backwards and we'll find out that the area scale factor is the linear scale factor squared. So we're going to work out what the linear scale factor is. So to find the linear scale factor, we're just going to square root the 30.25, the area scale factor. And when we do that, we get the answer of 9. So square root, 5.5 even. Didn't sound right. Okay, so when we square root that, we get 5.5. Now, we know that the volume scale factor is equal to the linear scale factor cubed, because there's 3 dimensions. So we know it's going to equal 5.5 cubed. And so the volume scale factor is going to be 166.375. Okay, so that's the volume scale factor. Now we're given the larger cuboid has a volume of 8984.25, and we're looking for the volume of the smaller one. So with scale factors, to get from the smaller to the bigger, we times it. To go the other way, we just divide. So we're going to divide this by 166.375. And then when we do 8,984.25 divided by the volume scale factor, 166.3275, we get the answer of 54. I'm going to first of all just focus on this rectangle here. And we know that to find the area of a rectangle, you multiply the two lengths. And when you've multiplied them for this rectangle, we get 697. But let's write down what A is equal to. And A will be equal to the area, which is 697, divided by the length at the top, which is x plus 30. Now let's focus on the other square, or the other rectangle. And this time we have A equal to the area of it, which is 1870, divided by the 10x. Now because both of these are equal to A, we can actually just get both of these fractions equal to each other. And what we can do is work out what x is going to be. So the first thing I'm going to do is I'm going to put my lines in, because we are looking to solve. This is probably going to take a while. And I'm going to times both sides by the x plus 30, so I can get rid of the denominator on the left hand side. And so this will just be 697 on the left hand side, because that gets rid of the denominator. And it will be 1870 times x plus 30, and then all of that over 10x. Same thing again, but I'm going to get rid of the denominator on the right hand side, so I'm going to times both sides by 10x. So we've got 697 times 10, which would be 6,970x, because it's 10x. And it won't actually do anything to the right hand side, but I'm going to expand the top, the numerator. It just gets rid of the denominator. So let's expand while I'm here. So that would be 1870x plus, was it 56,100? I believe that's right. Yep. Okay, so now we've got x's on both sides. So we look and see which one is the smaller amount of x, which is the 1870. and we're going to take that away from both sides. So take away 1870x from both sides, and that will leave 5100x on the left hand side, and then obviously we've got the 56,100 on the right hand side, and we want to get rid of the 5,100, so we're just going to divide both sides by 5,100. And so we've got x equals 11. So now we know x is 11, we can pick one of the equations that we had at the start, and I'm just going to pick the first one, and we can just feed in the value of x. So a equals 697 over, instead of x, it's going to be 11 plus 30. And when you do that, you get the answer of 17. So a is 17. So the first thing we need to realise is that we can create a right angle triangle from within this cone. So if I draw a line from the top going downwards, a line to the right and a line up, and we can label the sides. So we've got 30 here, and we've got 10 at the bottom here, and we're looking for this angle here, which we're going to call y. And if I just highlight all of this and move it across, then we're obviously going to be using trigonometry to find out what y is. So first step with trigonometry is, well, find out where the right angle is, which is there. And the one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. In this question we're not using the hypotenuse because there's no letter or number next to it. And so I'm going to do my SOHCAHTOA, SOHCAHTOA, and we're not using the H, so we're going to cross out these two. We're using the TOA, and that stands for tan the angle, which in this case is y, equals the opposite, which is 10, over the adjacent, which is 30. And so tan, so we're going to inverse tan both sides, so we're going to have to solve this. So let's get my lines in, and we're going to inverse tan both sides. So that will just leave y on the left hand side, and then we need to find out what the inverse tan of a third is. And the inverse tan of a third is 18.434 blah blah blah. Now what I did at the start was I moved the diagram away from the cone. Let's just move it back and we'll see the fact that y is exactly half of x, because we've done a line straight down the middle. So to find out what x is, all we need to do is double y. So x is going to be 2 times y, so that's going to be 2 times the 18.434 blah 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 blah, and so that is going to be 36.869, etc. And it says it wants it to correct 2 decimal places, so that's going to be 36.87 degrees. A line that has a gradient of 0 will just be a horizontal line. So if you get your ruler and you just have a horizontal line on your ruler, so just have it as a gradient 0, and just keep moving down this graph until it becomes the tangent of the curve. So if you see, it becomes a tangent to that curve here. Where is it a tangent to? Well, it's a tangent to this coordinate here, which is at x equals 2.5. So we've got x equals 2.5, and you can see the y is 2. So the coordinates are 2.5 and 2. You can see that there's a negative before the x inside the function for the graph which asked to draw, and what that will do is it will just reflect the graph in the y-axis. And so what we're going to do is we're going to just mirror this graph, and we can see it crosses the y-axis at 0, 2. And this is not the easiest one to draw, but we want it to kind of roughly reach the peak there, and then what's that, 2.5, so it'd be roughly there, and it will go off the graph about there, and it will reach the bottom about there. So we just want to roughly draw it out, and this is a kind of sketch because we can't be too accurate with this, and you wouldn't necessarily be expected to be perfectly accurate, but that's more than good enough to give you the mark. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.